Alright, today we're going to talk about linear equations and quadratic functions and modeling. So yes, I'm aware that this section starts off with 2.1, and in this class it's all about circling back to some things. So far this year it's been some review with some kind of weird new stuff. The new content will continue, but I'm hoping that with this section we may see some connections between last section and stuff that we've at least seen in Algebra 1 or 2. So, going back to the basics, which are lines. Yes, lines are functions as long as they are not vertical. So, the reason why that is because I wouldn't pass that vertical line test. Surprise! With these lines, there's a few things that we need to write an equation. One thing is a point and or points, and slope of some sort. So, all lines have a degree of 1. Meaning that they will have 0 turning points. The way that we have been told to find the slope in the past is m is equal to the change in y over change in x, which is that y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, which is true, and this idea now gets expanded to something called the rate of change, which is f of b minus f of a all over b minus a. Again, it's just change in y over change in x. It's just written a little funky. And honestly, this idea is the foundation for the first semester of calculus. But in pre-calculus, let's stick to the constant rate of change for now. Because again, rate of change going forward into calculus will be important. Alright, problem 1 says find the equation that passes through the points of -3, 2, and -1, 0. So again, we've got 2 points. I can find the slope by that change in y over change in x. So change in y, my y's are 2 and 0, so 2 minus 0 over, well, I started with 2, so now I need to start on bottom with 3 minus -1, which should be 2 over -2, otherwise known as -1. So m should be equal to -1, otherwise known as my slope is equal to -1. Alright, next one we have is f of 3 is equal to 9. Well, this tells me that I have a function of x. Well, x this time is 3, and I got 9. So my input that I plugged in was 3. I got 9 out. So that's my x, that's my y. Same thing here. I plugged in 2 for x. I got -5. So those are my 2 points. That's all that tells me. So f is a function of x normally, and I plugged in 2 for x. Alright, now I just do the same thing I just did, change in y over change in x. So I'd get 9 minus -5 over, I started with 9, so I need to start with 3 this time, minus 2. All in all, I should get 9 plus 5 over 1. That should be 14 over 1, otherwise known as just 14. And if you wanted to start the other way, for example, if you wanted to go -5 minus 9 instead, all over, started with -5, so I need to start with 2 on bottom, minus 3, I would get -14 over -1. My signs cancel out, leaving it just 14 here as well. Alright, so again, that's all there is. Just pick a point, that's your sub 1s. Pick the other point, that's your sub 2s. Whichever point you start with up top, you need to continue to start with on bottom when you go to that fraction change in y over change in x. So yeah, lines are cool, but we said something about quadratics. You're right, I did. Quadratics are just functions that we learned about first in Algebra 1, then again in Algebra 2, and the first form that we may have seen back in Algebra 1 was something called the factored form. And that's also what we took a look at this year, which is where we had x minus c times the quantity of x minus d. And this is where c and d are both roots, aka x-intercepts, with a multiplicity of 1, meaning that our graph would cross at both of these particular intercepts. The second form that we learned about, which is more likely called standard form, you may have seen sometimes this year in bell work already when I say hey factor blah. That standard form is as easy as ABC. That's as y is equal to ax squared plus bx plus c. The last form we should have learned is something called vertex form, which is y is equal to a times the quantity of x minus h squared plus k. We need to be able to fluidly move through these three forms, and the reason why is because sometimes one form's a little bit more helpful than the other. Alright.